Figure 4.1 shows the device used as a thermocouple thermometer. You can see this is a schematic figure for the thermocouple. In the table, put the three ticks against the correct statements about the thermocouple temperature. So we had learnt about the two kinds of thermometer which were based on the uh, electric properties of the material. We had seen the first one where we had used the thermistor, and the second one, which was the thermocouple, which was based on the principle of the Seebeck effect. So in case of the thermistor, we basically use the resistance property of the material. In case of the thermocouple, we use the principle that is called as the Seebeck effect. Okay, what was that effect we had learned? We generally use the two metal wires. So we can consider this upper one is the one metal wire and lower one is another metal wire. And these are the two junctions. You can see this one is the first junction of the metal wire, this one is the second junction of the metal wire. And what we had done, we had provided the heat. Okay, here we had provided the heat to this particular junction. So this junction becomes hot. This junction becomes hot, and this function automatically becomes cool. So you can see there is a temperature difference between these two junctions. Okay, this is the junction 1, this is the junction 2, and because of this temperature difference, we get the potential difference. Okay, because of the temperature difference, we get the potential difference, which can be used with this meter. Here, this meter must be the voltmeter to measure the potential difference. Okay, there is the occurrence of the potential difference, and once we get the potential difference, with the help of that potential difference, we can measure this temperature difference. Okay, so this was basically the principle which was called as the Seebeck effect. Okay, where we use the two metal wires which are connected so that we will get the two junctions. One of the junction is heated, so we will get the temperature difference between the two junctions. Because of that temperature difference, we get the potential difference, which is to be measured by this voltmeter. So here you can see in the table, put three ticks against the correct statements about the thermocouple uh, thermometer. So you can read the statements. Meter Z measures the energy. So this meter is unknown basically over here, and we don't know what this meter uh, change basically measures. So they are saying it measures the energy, and we know it can't measure the energy. It is measuring the potential difference. So the second statement, the meter Z measures the potential difference, and this is what we expected. So this can be our answer. So I put here tick. Now the third one, the meter Z measures the power, which is also incorrect. Now the materials X and Y are different materials. Definitely this must be two different wires. Okay, we are using the wires of the different material, different metals. So definitely this is the expected answer. So I will put here one tick. So the next statement, materials X and Y are the same material. We can't have the same material because if we have the same material, we can't get the temperature difference. Now the material X and Y are electrical conductors, so those must be conductors because we are getting the temperature difference only because the heat can be transferred. Heat can be transferred through this wire, and for the transmission of or conduction of this heat, these materials must be metal. These materials must be conductors of the electricity and the heat. Okay, so it should be the answer. Material X and Y are insulators, which is not the answer. Okay, so we put the three ticks. The Z, which is this meter, which is connected. You can also see this is connected in the parallel combination. Okay, this is once we have the two junctions. We know in the parallel circuit we get the junctions. Okay, and in the series circuit we don't get any junctions. Here two junctions are formed, So meter connected is nothing but the voltmeter that measures the potential difference. And the material X and Y are of the different materials. That's why only we get the temperature difference. And X and Y are electrical conductors, so that heat can be conducted through the wires. Now the part B of the question. The liquid in glass thermometer is replaced by a cellular thermometer with a larger bulb. Okay, and then no other change is made. State and explain the effect on the sensitivity. So we had learned what was the sensitivity. Sensitivity is nothing but the ability of the thermometer to measure the small changes in the temperature. Okay. So even the small, even if it is there, the small change in the temperature, there can be the expansion of that liquid we are using in the thermometer, and so that we can use the temperature of that small range also. So that property is nothing but the sensitivity, and how it is related to the bulb. We had learned that to increase the sensitivity of the thermometer, we can increase the volume of the bulb, or we can decrease the diameter of the tube. Okay, you can see this is nothing but the bulb, and this is nothing but the tube, or which is also called as the bow. So if we increase the volume of the bulb, the sensitivity will be more. So here we are going to increase the volume of the bulb. So we are using the larger bulb. So what will happen naturally? The sensitivity will increase, or we can write down over here. There will be, so we can write down here the sensitivity. The sensitivity will be more. There will be more sensitivity, and also we can observe another thing over here, that there will be the more expansion, and for even for a small change in the temperature, there will be the more expansion of the liquid, and that's why there will be, which is nothing but we can say the more sensitive thermometer, which can measure even the small amount of the small change in the temperature. So we can write down over here, there will be the more expansion of liquid. There will be more expansion of liquid. So these two changes we can observe with in regard with the sensitivity. There will be more expansion of the liquid even for a small change in the temperature, and which is nothing but called as the higher sensitivity. Now we will move toward the part C of the question. So part C of the question you can read over here. The capillary of the liquid in glass thermometer should have the constant diameter. Okay. The figure 4.2 shows the capillary of the thermometer made with the manufacturing fault. So we must have the constant diameter, and you can see the structure of the capillary. This is the thermometer, and some part is zoomed in. You can see this is a zoomed in part, and you can see this one is the glass, and this one is a bore or the capillary or the cavity. And here you can see it is non-uniform. Here it is having the smaller diameter, here it is having the higher diameter. So walls of the non-uniform capillary you can see, and the cavity is non-uniform, that means diameter is not constant. So state and explain the effect of this fault on the linearity of the thermometer. So we had learned the linearity. What is the linearity? That means if there is a thermometer whose capillary is basically having the a constant diameter, that means it should be the fixed hole, or the hole of the constant diameter, so that we will get the property of the linearity. What is the linearity? It is nothing but, suppose for a same change in the temperature, we will get the same expansion of the liquid. Okay, in the thermometer we know there is a liquid like the mercury or the alcohol, and if we heat the bulb, okay, when we heat the bulb of the thermometer, the